A uniform bridge of weight 3,000 tons is supported at each end by pillars which are 30 meters apart. A car of weight 20 tons is stationary at a point 5 meters from the left-hand side. Find the forces acting on each pillar. Now, 1 ton equals 1,000 kilograms. Pause the video now and have a go at this question. As always, we should draw a diagram of the situation. Here is our bridge. It's supported by pillars that are 30 meters apart. So the length of the bridge is 30 meters. Now I'm going to call these pillars A and B. You could call them 1 and 2. A car of weight 20 tons is stationary at a point 5 meters from the left-hand side. So we've got our force downwards, which is going to be 20,000 kilograms times by G. And that is at a distance of 5 meters. And then we need to put the weight of the bridge. So it's going to be in the middle. It's a uniform bridge, which means the mass is uniformly distributed. So we know that this distance here from one end to the center of mass is going to be 15 meters, or I can just write 10 meters here because we've already put that 5 meters on. And the force here is going to be 3,000 times by 1,000 G, or 3 times 10 to the 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 G. So let's pick a pillar. Let's say what is the force on A. So what we mean by this is what is the upwards force that A is providing. So to do this, we need to pick a pivot point. We could pick any point we want, but the far easiest point to pick is here, because then we can ignore the force from B. There won't be any moment from B if we pick B as the pivot. So moments about B to start with. It's in equilibrium, so we know that the clockwise moments will equal the anti-clockwise moments. So let's start to figure this out. So the force of A times by the perpendicular distance is going to be equal the other forces times by their distances. So 20,000 G times by this distance, which is 25 meters, plus 3 times 10 to the 6 times G, because we obviously need to get a force, not a mass, times by this distance here, which is 15 meters. Now we can solve this equation and get our force A. So 3e6 times by 15 plus 2 times 10 to the 5 times by 25 divided by 30, and that gives us 1.7, 1, 2, 3, 4, 5, 6 times 10 to the 6 newtons. Now to find the force B, we can do exactly the same process, but we can take our pivot point to be A, and that means we can neglect A. So we can say that the force upwards from B times by 30 meters is going to equal to this 2 times 10 to the 5 G times by 5 meters plus 3 times 10 to the 6 G times by 15 meters. Let's solve that, find out what force B is. And we get 1.5 times 10 to the 6 newtons. Now we can do one final check to make sure we're okay, because if we have some object and we have a force down on it, so we've got 3 times 10 to the 6 G, we've got 2 times 10 to the 5 G, and we've also got some forces up. So this force B is 1.5 times 10 to the 6 newtons, and we've got our force A is 1.7 times 10 to the 6 newtons. Let's see if all the upward forces equal the downward forces. And you can see that they do indeed equal 0, which we would expect because the bridge, of course, is in equilibrium. It's not accelerating up or down. So this is a nice little check to see that we've got the correct answer.